let's start with number 7. With the chain rule, okay? The important thing, the important skill with the chain rule is to be able to see functions as compositions, as basically the most simply that I've ever heard it put is a function inside a function. So you have to be able to see the function that's on the outside, quote unquote outside, and then the function that's inside that function. As I look at this one's a pretty simple one, a pretty a basic example of a function inside a function. If we look at this, we can see this is just a straight function that we could take the derivative of, no problem. So is this. We could take the derivative of this with no problem. Like we have, before the chain rule, we have all of the skills we need. 3x squared, 2, we're done. But with having a composition of functions, there is no rule until we learn the chain rule to take the derivative of it. Otherwise, maybe you could cube this out and then take the derivative of that polynomial, but that would take a long time. It would be really frustrating and needless because we have the chain rule. And the chain rule works like this. Once you've identified the outside function, something, I just call it something to the third. Once you've identified it, then you take the derivative of the outside function as if, this was x. Meaning, by that I mean don't change this, don't mess with this at all. Just leave it inside there and take the derivative of the outside function. So enough talking, let's see what I mean. What I mean is the derivative of something to the third would be 3 times the something squared, assuming that the something was like, the variable that you're taking the derivative with respect to, right? It's d dx, the change in y over the change in x. But it's not just x in here, and that's where the chain rule comes in. It's not just x, so what we also need to do is tag on the derivative of the inside function. And as long as there's a function inside the function we just took the derivative of, we need to keep taking the derivative. But that's it. It's just something in the third. And then 2x minus 7 is differentiable by the rules that we already know. Okay, so this would be 3 times 4x squared minus 28x plus 49 times 2. Alright, sorry about that phone call. Anyway, we've just expanded this, and we'll have 6 times 4x squared minus 28x plus 49, and, so on. I'll skip all the algebra nuances. They're not even nuances, they're basics. So, we'll go on to 8. Let's see, y equals 3 times 4 minus x squared. So slightly more involved, okay? So hopefully you see this, I kind of think of it as zooming out and seeing the whole landscape of the function, seeing, the whole thing as a whole. And seeing that on the outside, I've got this thing to the fifth. I've got this function in here to the fifth, right? This is the thing that's on the most outside. I could draw some more parentheses and have something that's even more outside of that. Also, tacked onto that is this multiple of 3. And from what we just did, we should be able to take the derivative of this thing right here. But then what do you do with this 3? The constant multiple rule says, this is one of the first rules we learned, constant multiple rule says if you have a constant times a function, then just take the constant and multiply it by the derivative of the function. That's the derivative of the whole thing. Okay, so that's just a little added thing. So we're just going to take 3 and multiply it by whatever we find to be the derivative. So again, the outside function, take the derivative of that, leaving this alone. So the derivative of something to the fifth would be a 5 times the something. Remember to leave this alone in here first. To the fourth. Okay, so I've taken the derivative, and if there's a function inside the function, which there is, I need to take the derivative of that. So negative 2x. And there you go. And certainly we could just go ahead and leave this like that for those of you in my class. Maybe we should throw a negative out there and make this just a 2x. Of course, we should go like this, negative 30x times 4 minus x squared to the fourth. And just expanding this out is just more trouble than it's really worth if you're not going to do anything else with the function, so just leave it like that. Let's give 23 a try. Alright, so we zoom all the way out, we see the entire landscape of the problem here, of the function. And what I hope we see right away is we have a function here and another function right here, and they're being multiplied together. They're a product of functions. So one thing I should recognize is that I'm going to be using the product rule. So that's one thing. And I could really just go ahead and get started on that. Just start with the product rule. You see it, you just start going at it. So take the derivative of this, 2x times this left alone, plus this left alone times the derivative of this. Oh, now we come upon this composition of functions. Something to the fourth, that's the outside of that function right there. X minus 2 is inside there. So we take this, according to the product rule, take this and multiply it by the derivative of this. The derivative of this would be 4 times the something to the third, right? That's the outside function's derivative, times, if we have a function inside, which we do, we need to take the derivative of that. Turns out to be 1, so it doesn't really change much. And let's just simplify this out. 4x squared times x minus 2 to the third. Okay, and that's pretty much as good as it'll get. 30 h of t squared over I believe I have that right. It's good. Okay, so we look let's just start applying the rules as we see that they're appropriate. Zoom out and see the landscape. It's something squared, so I know how to take the derivative of something squared. It's take that exponent and bring it down here, multiply it by the something. Great, and then that's to the first. Okay, now I see, yeah, there's a function inside this function squared, so I need to take the derivative of that. So I go to take the derivative and I realize, oh, right, I have to use some other rule. It's not as straightforward as just, the power rule or something. And I'm trying to figure out, what do I do? It's a quotient, they're divided, so use the quotient rule. So quotient rule is derivative of the numerator times the denominator minus the numerator times the derivative of the denominator all over the denominator squared. And we just have a lot of time-consuming simplification that can happen if we want it to. Oh, let's make this 3t to the fifth, and this will all be over t cubed plus 2 cubed, because I multiply these two together. And you can just keep going from there. If you have a binomial squared, expand that out. Anything bigger than that, don't expand this. This has a little more trouble than it's worth, but go ahead and simplify all that other stuff. And okay, 41. I'm going to throw some trig functions in here so we get some practice with that. Okay, a pretty basic one so that we can identify the outside function and the inside function. The outside function is the cosine of something. Cosine of 3x. So I start taking the derivative. The derivative of the cosine of something is the negative sine of that something. Right? And then I see this is not just x alone in here, so I need to take the derivative of this inside function. This 3x is inside the cosine. So times the derivative, which is 3, so negative 3 sine of 3x. Okay. Next, 55. Tried to pick the craziest looking one I could find so that we can pick it apart together. First I'm going to rewrite this just to remind you, in case you had forgotten, that this secant, this squared here by the secant, means this. Right? We're taking the secant of this thing, and then all of it is being squared. So hopefully you see that's exactly what this is. Okay. So we've got this constant, actually I should go up, no, it's constant times this function. So the derivative is going to be that constant times the derivative, whatever we find here to be the derivative. So let's look on the most outside that we can find for this part of the function. Not looking at the 3, it's already taken care of. The most outside is something squared. Okay, so take the derivative of something squared. 2 times the something, that something is all of this. Okay. But what we see here is it's not just any something, it's not just like, not just t, it is this whole thing, which means use the chain rule. The derivative of secant is, or the derivative of the secant of something would be the secant of that thing times the tangent of that thing. Times the tangent. Okay. So I did the most outside was something squared, took the derivative of that. Inside of the something squared was the secant of something. So I took the derivative of the secant of something. But even inside the secant of something is another function. So inside the secant is this pi t minus 1, so we got to take the derivative of pi t minus 1 with respect to t. And the derivative of that, remembering that pi is a constant, it's just a number. So we got a number times t, the derivative of a number times t would just be pi. So what do we have? 6 secant squared pi t minus 1. Let's make it 6 pi. Bring in this pi over. Times the tangent of pi t minus 1. There we go. Okay. I believe we have one more we're going to do. Number 86. This is, in your book it doesn't have parentheses here, but it's understood, you know, this pi times x is going into the secant function. That's your input of the secant function. Put in for x and multiply by pi, take the secant of it, square that. Okay, and the directions for this say take the second derivative. So to take the second one, we first have to take the first one. And the most outside thing is, remember, the squared, because it's the same as if I put parentheses around here and squared it. So the derivative of something squared is 2 times the something. And then we look inside that function squared, and we see the things being squared is secant of something. So I need to take the derivative of the secant of something, which is secant tangent. Alright, so I took the derivative of the most outside function with something squared. That's where that came from. Then I went inside the function squared and I found secant, and the derivative of secant is secant tangent. Then I went inside secant now and I find pi x, and I need to take the derivative of that inside function, which is just pi. Okay, so let's write this a little neater. 2 pi secant squared pi x times tangent of pi x. Okay, so remember it said find the second derivative. So we're going to find the second derivative. Constant multiple rule says just write the 2 there and then take the derivative of everything, so we'll do that. So take the derivative, 2 pi actually, because that's a constant. Take the derivative of this stuff here. Let's draw a box around it. We're going to take the derivative of this, and here's what the derivative is going to be. Just keep writing. Yeah. Okay. How do I take the derivative of the stuff in this purple box? Well, it's a thing times a thing. It's a function of x times a function of x. That's called a product. So we need to take the derivative of this product with the product rule. So the product rule says first thing, take the derivative of this. Now this is convenient because we just took the derivative of this. You see, this is the exact same thing. So actually, here we have the derivative. So let's just go ahead and write that down. The derivative of this is 2, let's throw the pi in front here. 2 pi, actually this is also the derivative. This is a cleaned up version. So 2 pi secant squared of pi x tangent x, or pi x, tangent of pi x. There we go. There's the derivative of this first part. That's for the product rule. Next part of the product rule is multiply that by this, just the function. We should back up just a second. Because, why? Because we took the derivative of this. Actually, no, that's good. We're done. We took the derivative of this. This is the derivative of that. So the chain rule has been applied already, and so we're good. So next, the rest of the product rule. Secant squared pi x times the derivative of the tangent of something. The derivative of the tangent of pi x. Derivative of the tangent of something is secant squared of the something. Right? And then we've just now tried to take the derivative of this, tangent of pi x. But it's the tangent not of x, but of pi x. There's a function inside of the tangent function. So we need to use the chain rule, multiply by the derivative of this, which is pi. Okay. So that's the end of the derivative of the stuff in that box. Let's just do a few things. This here is this function. Its derivative is all right there. This one, we took the derivative of it, and that is right here. Okay, using the product rule. Let's just do a little simplifying maybe. Let's distribute this 2 pi in here, so I'll get 4 pi squared secant squared pi x tangent squared pi x, because the two tangents times each other, plus, I'm still distributing this 2 pi, so 2 pi times pi is 2 pi squared secant to the 4th pi x. So we got 2 secant squareds here. So there we are. Yeah. And that's it. That's the last one for this section. Hope that was helpful.